All right.
So very good morning to all the students and faculty who are attending this session. We have got faculties, we have got students, Vaibhavji from not only from Amity University, Uttar Pradesh, Noida, they are from across all the campuses. Amity has more than 10 campuses in India, full-fledged universities, and 17 plus global campuses. And just to mention before starting this session, we have curriculum which we have realigned based on Industry 4.0, and we have introduced courses which are based on data science, cloud computing, artificial intelligence, network security, which are the area where a lot of demand is there. And so we have realigned our curriculum and ensure that each and everything which has been taught must have an impact on their student learning experience. And based on these courses which we are talking and on which you are giving talk, many students have also got an opportunity to do internship. And when they're going in placement, they're getting a lot of benefits. So today we have kept your session on data science in action, and we'll be talking about on machine learning. Dear students and faculty, we have got Vaibhav Srivastava, who is a data scientist with Deloitte. And Vaibhavji, many students from Amity are in Deloitte and they're really enjoying. You have got a very good culture. And I'm sure your talk, your address will add a lot of value, because students, when they go for a placement, we arrange some special talk for them so that they can understand industry trends and get some idea by person who are in industry. So your talk will be very important for them. On that basis, they can get the feedback. What are your expectations? And I'm sure if they got those ideas, they can prepare themselves well. And we are going to start placements from September. And I'm sure post-COVID, we always tell them you have to be well prepared now. Jobs are always there, will always be there for person who are competent. So job problem will only be there for the students who are not up to date, who does not know the industry trend, who are not prepared with that. But technology like machine learning and data science very much in demand. And I was going through that you are tech speakers and you are also cloud, Google Cloud architect. Just to mention,
Hello. Hey, am I audible?
Yeah, you're audible now. I request Mr. Srivastava to start your session, please.
Sure.
And we have asked all to have question answer session at the last, followed by your session, please.
Sure. All right. So first of all, thank you so much, Mr. Abe, for having me here. It's a pleasure talking about something that I'm passionate about and have been doing for a while now. What I'm going to be talking about today is data science in action, right? So you would typically, if you just search the word data science on Google, right, you would find multiple links saying that, this is what data science is, this is what machine learning is, and this is what computer vision is, and so on. What a lot of these links not talk about is how do you actually see data science in production, right? A lot of our students, a lot of our young generation right now knows a lot about how to build a machine learning model, but they don't know how to actually go ahead and put it into production and build services out of this and actually build something that can go on for masses. This talk would predominantly be focused on how do data science teams actually work, and we'll take a case study right from the start about recommendation engines, and we'll actually go all the way till deploying that, right? And we'll see what are the phases, what are the considerations that we take for building such data science systems, right? So throughout this talk, feel free to put your question answers in the Q&A section. Should you need to reach out to me, you can reach out to me on Twitter at reach_VB or on LinkedIn to the link provided to you. You can also write an email out to me at webabwestin@gmail.com as well. Let me just go to the next slide. So before I get started, let me just give you like a quick one minute or half a minute view of who am I. I'm Vaibhav Srivastava. I work as a data scientist with Deloitte Consulting. I've been doing so for past 3 to 4 years, and I have been consulting with Fortune Technology 10 clients, building machine learning workflows for them on Google Cloud, right? And typically every time someone asks me that, what do you do when what do you actually do when you say that you're a data scientist? I say that this comic pretty much depicts my work, that given like how vast and deep the realm of machine learning is, it's basically spending a lot of time trying to figure out what kind of equation makes a lot more sense, what data points should be put into the model and whatnot. So a lot of my job is experimentation and actually figuring out what does not work than figuring out what works. So enough about me. We've been talking about data science, we've been talking about machine learning for past 1-2 minutes, right? And in its entirety, let's just scratch the surface with what exactly is data science, right? So if we were to look into the Wikipedia definition of what data science is an interdisciplinary field of scientific methods, processes, algorithms, and systems to extract knowledge or insights from data in various forms. Now, this data can either be structured or unstructured, similar to how data mining works, right? So just to give you an example, right, we currently are surrounded by a lot of applications of data science, right? Just for an example, with Zoom, right? Like right now, you see my live feed, right? But I can switch to a virtual background on Zoom, and I would have a background behind me masking all the curtains behind me or the backdrop behind me, right? And what the Zoom background masking does is it basically runs an image segmentation model, right? It segments me from the background itself, and it would overlay some other background on it, right? That's the most simplest applications of machine learning. If not that, if you use an iPhone or if you use a Google Assistant, right? As soon as you say hey Siri, or you say okay Google, or something like that, you would see that you will get a response as soon as possible. So what that means is basically there is a machine learning model which is embedded into your mobile device or as an API, which is taking that audio from what you're saying. It is actually understanding that audio, and then it goes on ahead and processes that and gives you an appropriate response. So if right now, if I say, hey Siri, call my mom, it would automatically understand that I am asking it to call my mother, right? And that's again another application of machine learning, right? The last one which I would like to use is if you've traveled abroad, you would see that say for example, if you go to Germany or if you go to any other country which has a different language in that sense, right? You can, just by using Google Translate app, you can just point your camera at a particular banner or at a particular text, and it will automatically convert that into English, right? That's like a twofold application of machine learning, right? First is image to text. So it looks at the image, it extracts all the text out of it, right? And then second is a translation problem. So what it would do is it would take that text, which is probably in German or Russian or like whatever X language it is, and then it would convert it into Y language, which is English. So there, if you demystify it, there are essentially two machine learning models working over there, right? Both one in the realm of computer vision, another one in the realm of natural language processing, right? Specifically text translation. So if I was to sum this all up, data science or machine learning is nothing but the field but the capability through which you can understand large amounts of text and make some inferences out of it, right? I'm just going to take us all back to like our sixth or our seventh, class maths, where we learned that, each and every equation or each and every or different data points have, um, you know, so a lot of data points would have, a particular solution in mathematics, right? Say, for example, if I give you x variable and y variable as 2 and 2 and 4 and 4 and 8 and 8 and so on and so forth, that's an x equal to y relation, right? What machine learning does is it actually helps us in getting to this equation faster, right? So instead of us manually solving an equation for a particular data point to a particular label, right? Machine learning helps us in defining a mathematical equation that solves for the data and a given variable in that sense, right? I know it may not make sense right now, but as we go through the session, I think it will start making a lot more sense. So we just spoke about a lot of things in terms of like, what is machine learning and all of that. But the most simplest example of this is, of machine learning in action is typically if you were to, if you had a database, right? And if you were to, find restaurants serving Chinese food in Gurgaon, right? How would that look like? How would you do that? You would write a SQL query like, select restaurant name, restaurant address from restaurants. Restaurants make the name of the table, right? And then you would put in two constraints over there where city is equal to Gurgaon and food type is equal to Chinese, right? Now, for people like you and me, this would be easy, right? Because we know how SQL works, how the structured query language works. We know the basics of it. We know the highs and the lows of it. So we should be able to write it. But what about all the other people, right? What about people who haven't studied computers in their in college or in school? For them, we need to come up with a way for them to be able to interact as if it was just a natural conversation, right? And for them, the way they can interact with a database like this would be, where can I find some Chinese food in Gurgaon? This is basically an English text wherein we can use this text and then we can process it using named entity recognition and other realms of natural language processing to figure out what is the food type that the consumer is looking for and what is the city in which they're looking it for, right? So again, this is the most simplest application of machine learning again, right? Now, you can just say the same thing to Siri and it will give you some results, right? So next time when you ask a question to Siri or ask a question to Google Assistant, just bear in mind that it's not just like what you're saying, but it's actually a machine learning model in the back end, which is actually processing your entire voice sample and is actually figuring out what do you mean by that. It's figuring out the intent of that, and then it's actually drafting an appropriate response and pushing it forward to you. So this was like a quick 5-minute background into what data science is, and how why it is, and how it is, how we as humans have kind of been around such services for a very long time, right? Now, for the rest of the course of the talk itself, what I'm going to be focusing on is an application of recommendation systems, right? And I'm just going to be talking about what this case study is, but just bear in mind that throughout this case study itself, right? Ask as many questions as you have. Feel free to stop me if you don't understand something, and try and relate this with real world scenarios, and just not try to relate everything with a text. So enough about that. Let's quickly go to the problem statement, right? So the problem statement is that you own say a footwear shop, right? And say you own a footwear shop and you want to create a web store for your footwear shop, right? Now, what you want is every time a person um, comes to your web store, right, and selects a product, you want to give them a couple more recommendations, right? This you can think of it as similar to how Amazon works, right? Every time you select something, at the bottom you would see that here are a couple of things that you can buy as well. Here are some couple of similar items that you can buy as well, right? But how do you actually build it, right? And again, you have attributes for a particular, say for example, in this case, right, you're the green person, and the like what the person's kind of viewing right now is a black shoe. Right now, each and every shoe would have a couple of attributes to it. You would have the brand, you would have the color, you would have the style, and you would have a couple more such shoes or such items that are there in your store, but your consumer may not go over there, right? So the task at hand for us is to build a machine learning model for it, right? Now, before we get into like how this would be built, and we'll touch base upon the math behind this as well. Just looking at a very high level, right? If say for example, if I who had no knowledge about machine learning, how would I take care of this particular problem, right? I would probably look for similar looking shoes, right? So say for example, if I see a black color shoe, what I would look for is other black color shoes, right? Or maybe I may look for the same style of shoes, right? Maybe it's a shoe with laces, or maybe it's a sneaker, it's a particular type of shoe, right? So what I can do is I can similarly find I can simply just find similar products, right, to that shoe and recommend to my consumer. This does not involve machine learning as such, right? Think of it yourself as a salesman in that store. You can quickly recommend them that, hey, this is the product that you can look at, right? And this particular type of recommendation is known as content-based recommendation, wherein I look at what you're viewing, right? Currently, I take the attributes of those. So those attributes again being brand, color, style, and couple others. I take those and I look for similar products for those, right? And essentially say that, hey, you know what? There is another shoe probably by Adidas or from Puma that you can buy, right? It's similar to what you're looking for. It's in the similar color. It's in the similar style. Why don't you go ahead for that, right? Second thing, which is a more machine learning way of doing this, is a collaborative filtering approach, right? The collaborative filtering approach is analogous to what you see on Amazon, right? Below Amazon, you would see that customers who bought X also bought these things. So say for example, if I buy a phone, the carousel below would say that customers who bought an iPhone also bought a screen cover or a back cover or an or a tempered glass or something like that, right? And that's basically collaborative filtering, wherein you look at the consumer and the product matrix, right? And you basically recommend that, hey, you know what, like people who have same characteristics as you, who were buying the same things, they also bought this thing. So we think that you can also buy you can pair these things together, right? And that's the collaborative filtering approach. Now we're going to be talking a bit more about these in the slides to come, but let's look at the end-to-end architecture of this recommendation model, right? I'm sure by now you would have understood like the two broad, like at least the intuition behind the two broad ways we can do recommendations. But let's look at the end-to-end flow, right? So you are, let me get my pointer out. So say you are this this man, right? Or this is your consumer. They come to your web store, they look at a black shoe, right? Now you can now you have two options, right? You can either look at the attributes that the product itself has, right? And you go through your database and you see that, hey, like there are a couple other shoes that look similar to it, and you send them to your recommendations API, right? Sorry, you send them to your recommendations API, right? This recommendations API then creates a list of all of those shoes and so on, and provides it back to you, right? And then, whatever the consumer does, either he or she buys or he or she does not buy, we log that into logs, right? And then we can iteratively, what we can do is, when more and more consumers come in, right, we can switch to a collaborative approach. Say, for example, when hundreds of people have gone through one listing, and we have enough behavior from them that they bought black shoe, they bought red shoe, they bought green shoes, or like whatever it may be. When we have enough behavior of them, then we can switch to a more machine learning based approach, right? And again, even with the machine learning based approach, you only get what kind of products can they go for, right? You still have to go to the database, fetch the details of all of those, feed it into your recommendations API, and then that recommendations API actually goes and shows it on the web store itself, right? So building the model is just like is just the 30 or the 40% of the task itself. Building the rest of the pipeline for getting your data from here all the way till the web store itself is the other 60% of it, right? And which you have to take care of. All right. So we spoke about two approaches here, right? One was a content-based approach, and the other was a collaborative filtering approach, right? Let's dig a bit more deeper into this, right? So if I look at if I start off with collaborative filtering, right? What collaborative filtering does is it would look for similar users, right? How does it look for similar users? Is by analyzing your buying patterns, right? It would look at similarity between whether I or probably Mr. Abe has same reading patterns or same buying patterns and so on. If those are similar, then you recommend whatever has been then the model would probably recommend whatever Mr. Abe has viewed or has read to me, right? Because we're similar in nature. The hypothesis here is that if there are two similar users, then their overall reading patterns or their buying patterns or whatever patterns you're trying to analyze, they would be same as well, right? So that's what collaborative filtering does. It would look at it would work at a grain of user and product, right? So it would look at a user and their overall history of what all products have they looked at, right? And believe me, this is a bit more complicated than a heuristic based model or a rule based model or something which is like a content based model, right? Now, how a content based model works is it would just look at the product or the article in this case, right? So let's switch gears and let's take an example of articles in this case, right? Say, for example, you're on Times of India, right? You read an article about, for example, coronavirus, right? And automatically the algorithm in the backend of Times of India would start recommending you other reads, right? So it would start recommending you that, hey, look at all the vaccine trials that are happening for coronavirus, right? Look at all the other things that all the states are doing for tackling coronavirus. It would start recommending you articles which are similar in nature, right? And that's a very simple content-based filtering model, right? So essentially, what you're doing is you're trying to find similar articles to what the consumer is reading and give recommendations accordingly, right? The hypothesis here, again, I'm focusing on hypothesis a lot, and I will come to it again. Why? The hypothesis here is that a user who's viewing something in terms of a product or is reading something in terms of an article would have more or less similar, would be inclined towards reading or buying similar products or articles, right? That's the hypothesis. Now, before I move to the next slide, I want to take a minute and walk you through the importance of hypothesis, right? For any machine learning exercise, for any data science exercise, what is the most important is to have a hypothesis, right? So in our case, when we're trying to build a recommendation engine model, right, we need to come up with like a broad hypothesis to whether it would be a collaborative filtering model or whether it would be a content-based filtering model, and we have to like define certain assumptions for it, right, as well. So for example, in in a collaborative filtering model, my assumption was that similar users have similar patterns in terms of buying, in terms of reading, in terms of everything else, right? Whereas in case of a content-based model, my hypothesis there is that whatever a person is reading or is viewing, they would tend to buy the same thing, or they would tend to read similar stuff alongside it, right? And like throughout your data science exercise, what you would be doing is essentially try to um, prove this hypothesis in its entirety, right? So let me just move on up ahead. Right. So this is a bit of like mathy stuff, wherein like we define how do you actually build the recommendation engine model, right? Now, just a quick refresher, right? What we're trying to do here, we're trying to build a recommendation engine model, right? So up until now, what have we done? We've looked at how the end-to-end flow looks like, right? That there is a consumer that comes to my web store, right? Then they review something, and then we expect to give them some sort of recommendations, and we hope that they actually buy something out of it, right? Now, we've spoken about two broad types of the recommendation engine itself, right? One is a collaborative filtering approach, and the other is a content similarity approach, right? Now, given that we've done all of that, let's do a bit of a deep dive of the math behind it, right? How does that recommendation engine actually works, right? So I won't go into too much of details of how that entire flow of math works, and like how do we minimize similarities and so on and so forth. But in the at a 10,000 feet level, right? What do we do is we basically give a data set, right, which has three parameters to it, right? So we give like a relevance for the user, right? Second, we give a rank to each and every product within our web store, right? And then we give basically different features of an item, right? And in our case, features of an item would be the color of the product, the type of the product, the shape of the product, the brand of the product, and so on and so forth, right? And what we do is, for each and every user and their interaction, right? Interaction meaning what all products they saw and their features, right? So it's if you look at it from a matrix perspective, it will be a product cross consumer matrix. For those, we pull all the values, right? And then for different people, right? We basically calculate similarity between the two, right? A similarity between the two can be something as simple as cosine similarity, right? Wherein you're basically looking at two vectors, and each vector would be a product cross consumer vector for each and every person. And then you basically look how close are they, right? So you find the cosine similarity of those, the cos theta value of those, and if it's something which is closer to 1, then that means that they're very similar consumers, right? And then what you do is you will get a ranking metric at the end of the day, which would be between 0 to 1, right? So essentially 0 meaning that the two consumers are not similar at all, 1 meaning that they're very similar to each other, right? And based on that, you give them a recommendation, right? So again, the the equation may seem a bit daunting, but that's all it is doing, right? It's actually just minimizing. It's in fact not just minimizing. It's actually just finding similar users with similar buying patterns, right? And typically, you would spend about 30 to 40% of your time defining such equations, or writing the code base in your language of choice, maybe R, maybe Python, whatever it may be, to actually replicate these equations in its entirety, right? The reason why I put it here is because when we generally look at data science, it looks like a very a very jazzy place to be in, but it also involves a lot of knowledge of mathematics, and like how do you define the interaction between users and their products, and actually code those up into a language of your choice. Okay, so Now that we know how the model would work in from a math setup, right? Let's look at it more from a programming setup, right? From an analytics point of view, how would this look like, right? And I'm going to be drawing parallels with, like, with big data technologies, and where exactly does everyone fit in, everything fit in, right? So if I go back again, right? So I have two key components in terms of data set from my web store, right? The first one is the database itself, which houses all of my item details, right? Item meaning my shoes, right? Then I have the logs. Logs are tracking my consumer behavior, which is what did the consumer look at, what did they view, what did they end up buying, what did they not buy, and all of that, right? So what, like, the first part of all of this would be that I combine the two data sets at a consumer level, right? And I get some raw data out of it, right? And then I do some feature extraction or pre-processing on this. So what is this feature extraction and pre-processing, right? This is basically, if in case I'm looking at shoes, right? Then it's the features of those would be me extracting, like, features like what is the color, what is, how much time did a particular person look at that particular image, and did they actually end up buying or not, and so on and so forth, right? If those are images, then pre-processing them into a state wherein the machine can understand them. That all comprises of feature extraction and pre-processing, right? And essentially, what you're doing throughout the process of converting your raw data into features is you're essentially creating data points that your machine learning model can easily understand, or can easily learn from, right? That's the key here, right? So you're not doing anything for the sake of anything. You're basically trying to extract features which define your data quite well, right? And again, this would be very subjective to what your particular use case is, right? So in our case, it would be majorly around, like, color, brand type, buying patterns, how much time did they spend, what mobile device are they using, and then so on and so forth, right? And then like, once you've figured out what features are there, then you pass it along to a learning algorithm, right? And this learning algorithm is nothing but a machine learning model, right? It is similar to what we discussed before, right? So in this particular slide, we put some math code. Even if you were to just write that in MATLAB, or say Python, and just put it into a function, that would be your learning model, because what your model is learning is how similar to users and products are, right? And then you basically persist that model, meaning that you save the model, right? And then you run it on future data, and give recommendations to people, right? Again, what we missed is this, like, what I just walked you through in the past 1 minute was like an end-to-end flow of how a machine learning model is developed, right? But in reality, right, it's not something as simple as you reading your data into Python or you reading your data into R, right? It is actually much more complex than that. Given that you would have, like, large amount of data, at least like terabytes, in some cases petabytes, right? You would need to know how to work with distributed systems, right? So for example, when I'm just merging my databases and my logs, right, I cannot do like a simple left join, or like, like an outer join, just using a SQL database, right? Because the volume of the data would be too large. So I'll have to use something which would be which would involve MapReduce, probably like Spark, or some sort of big job, or something like that, right? So I'll have to write those into a different framework than other, right? When I'm doing my feature extraction and pre-processing, depending upon how much data am I actually using, it can be MapReduce, or it can be done using Python or R or Dask, or some sort of platform like that, right? Generally, the piece in red, which is learning, right, that is something that can happen in, like, any language. It can happen in MATLAB, it can happen in Python, it can happen in R, it can happen in Scala, Julia. Pick your favorite language and you can do that, right? And then again, once your model is built, right, then when you deploy it, for you to infer it for future data, because you'll have so many people coming to your web store, right? You'll again need a distributed system. So again, it'll mostly be map reduced, and you'll have to build probably something using Spark streaming or something, or Apache Storm, to actually get those streams of data and infer your model on it, right? So again, so it is like just building the machine learning model, as you can see here, right? So there are 1, 2, 3, 4, 5, 6 steps, right? Out of this 6 steps, building the model is just one step, right? So again, one key message from this slide for you all is that don't just think that building a model is everything, right? There's a lot that goes in the back end and in the front end, and when you actually go out there in the industry, you will be expected to do all 4, 5 of these. Not just like importing scikit-learn, importing TensorFlow, importing PyTorch, and building a model out of it, right? And that's the key thing. Cool. So again, and you may have realized up until now that what I'm trying to do is I'm trying to build like a overall journey of how a data science project works, right? So we first looked at what kind of problem statement we have. We saw 2 types of models that could be applied there. We did a bit of a deep dive into how those models actually look like in terms of the mathematical equations, right? And then we discussed how what kind of technologies can the flow of joining the 2 data sources, getting features out, building the model, how those can kind of work with each other, right? Now let's look at, given the fact that you've built the model, how do you serve the model, right? So if you look at the screen right now, what's happening here is that you have events happening. Events are nothing but people like you and me going to our web store, right? Going through all the articles, going through all the articles in here mean all the items that we have, right? So shoes and sandals and slippers and stuff like that, going through all of that, and these are all logged. Then you can see here that you have like a pre-process features. You have a pre-processing pipeline, right? So which is again doing the same thing, which is extracting all the variables that my model uses, right? Passes them along to the learner, and once it passes to the learner, which is nothing but the machine learning model, it gets the recommendations and sends the recommendations over to the user, right? Now there are a couple of things that we did not speak about here, right? Like, how do you evaluate your model, right? Fine, there is the whole statistical way of finding the accuracy, the F1 score, the precision of your model, or how accurate your model was using a testing set and so on. But would a business, or would a firm be okay placing such a huge bet as recommendations just by those statistical measures? The answer is generally and in most cases no. Right? So not a lot of firms would care about. Yes, they would like their data science teams would care about values like accuracy, F1 score, and so on and so forth. But generally, you would have to come up with some sort of KPIs, right? KPIs are nothing but key performance indexes, right, or indicators. And what these key performance indicators would be is something that you define generally with your business. So let's define a few KPIs for our use case, right? So we're building a recommendation engine model, right? A very simple KPI for my recommendation engine model could be something that is like, for example, how many times did a person actually click on a recommendation, right? Or how many times did a person actually buy something from a recommendation? Is that 2% at a times? Is that 4% at a times? Is that 5% at a times? Or 15% at a times? The higher that percentage value, the better it is, right? So that's one KPI, right? Second KPI can be how many times did the user, after looking at the recommendation, not end up buying something, right? This grows to tell me how many times is my recommendation a bad recommendation, right? So the lower that percentage is, the better it is for you, right? So like when you're going through the whole machine learning exercise, right, you would be defining a lot of these KPIs, right? These KPIs can be, any of those that we just spoke about, right? But you would be defining those, and you would be creating pipelines, you would be creating dashboards which are indicating these KPIs. So another key message here, right? Whenever you're building a machine learning model, always look at it from an industry point of view, from a business point of view, that what are those KPIs that my model is fixing? Because somewhere down the line, you would be reporting to someone who's probably a CDO, which is a chief data officer, or a chief digital officer, or a CTO who's a chief technology officer, and they may not be inclined towards looking at your accuracy scores or your F1 scores or your model metrics. What they would be more inclined to see is how does a particular model impact their revenue? How does a particular model impact their um, overall number of people coming to their web store, and so on, right? So be mindful of that. The second key learning here is that you will have certain constraints, right? What these constraints are, and specifically to serving the model, is how many number of requests do you get, and in what time do you give out recommendations? There would be a particular time frame for it. So for example, if you go on Amazon, it takes less than 2 milliseconds to get recommendations, right? So you would have to create a distributed system for your web store which handles that level of recommendations, right, in that quick turnaround time. So you can look at different things like TensorFlow serving. You can look at Java-based frameworks like Spring to deploy your model and so on, right? But again, that's another key part of the whole process, which actually talks about how your recommendations are served, and the constraints being how quickly you want your recommendations to be served and how many requests do you get, right? So for example, if you've seen Amazon's Big Billion Days, right? How many times have you seen that you may not just find anything on those days, right? That's because millions of people are trying to get to the website, and your machine learning model is serving them recommendations. They're clicking on those. There are a lot of tracking happening, and all of that, and it's just not able to handle that much load. So building a distributed system there is again a key. Let's move to the next slide. And I'm nearing towards the end of my presentation, so keep your questions ready in that case. So now that we've spoken about how model serving works, we've spoken about how the model is built, we've spoken about how what's the math behind it, we've spoken about what kind of models can we use. We've also spoken about the data itself, right? So this was like a backward journey up until now. Let's look at the big picture, right? So how does this all sort of come together, right? So here's you, right? Here's the web store. We log some data into it, right? You get some data in. This would, again, since there is a lot of people coming to your web store, this would probably have to be done using Python, Spark, some sort of distributed technology in that case. This then goes into features, right? You extract features out of it, you build a model out of it, you evaluate that model. And again, this is an iterative process, right? As and when you add more products into your web store, you would have to retrain the model. You would have to like retrain the model again and again to get such insights, right? Once you're okay with the model, you put this model into production, right? One thing that again keeps on happening is A/B testing, right? So A/B testing, let me just spend a minute on that. What A/B testing does is it would take a couple of features, right, of your model, right? So for example, if I built a content-based model, it would, out of the 100 people that come on my store, it would randomly select 1 or 2% people, right? And it would show them a different variant of my model, right? And then it will track how their usage is. For another 2 or 3% people, it would just not show any recommendations and see how their and it would see that how their overall behavior is, right? And we do that for different models, right? So essentially, towards the end, what happens is you actually see what is the impact of your model, right, on different control samples, right? This is analogous to how testing of a vaccine does happen, right? You have different vaccines, you give it to different control section of people, and you see what their impact is, right? And this helps you remove any bias in terms of building your model or in terms of putting your model into production. So this actually helps you in getting to a point wherein you you know that your model is good enough um, for your use case, right? And then when once your model is built, you basically put it into your production system, right? This by and large in the industry happens using Java, right? I'm not gonna deny this. There would be there are a lot of frameworks like Spring. There are quite a lot of utilities in Spark to deploy a model using a Spark MLlib and so on, through which you once your model is built, you deploy it into your production system using that, right? So the lesson that I want you to take from here is that, again, building the machine learning model, which we like, really kind of bump up in the market right now, is just one piece of the overall big picture, right? There are a lot of things that happen alongside it, behind it, and outside of it, right? So whenever you're like learning data science, or whenever you're like equipping yourself to build a career within data science or within machine learning, right? Keep into mind that all of these factors are something that you'll have to take care of as well, right? So it's not just building the best possible model on Kaggle, right? It is building the best possible model and also putting it into production, and also running A/B testing on it, also running also building KPIs on top of it, which actually explain that model to a business user, right? Now, this is probably my last slide, but I just want to give you a sense of, because I generally, like, whenever I go out to speak at conferences, I get this question a lot, like, what is the difference between a developer, a data scientist, a machine learning engineer, and all of that. So I put this slide together to actually walk you through those. So like, if I was to draw a graph between exploration, design, and coding, right? So a data scientist would do a lot of exploration, right? They would look at the data, they would extract different features out of it, right? And there would be no defined goals, right? Because they themselves don't have like a goal to achieve. They're looking at the data, they're trying to make sense, they're trying to build those hypotheses, right? So in our case, our hypothesis was in terms of content based, in terms of collaborative written based, and so on, right? And again, the kind of code they would build is like one-off throwaway, right, code, meaning that most of this code would not go into production, right? Whatever inputs your data scientist gives, right, those become the whatever outputs your data scientist give, those become the input for your machine learning developer, right? So they would basically start off where the data scientist ends, right? And they would take that code, they would take that design, they would take those equations onto production, right? If you look towards the right side, you would see that, like, our data scientist is basically responsible um, for the data, the analysis, giving some documentation for it, right? Then doing some exploratory analysis, pushing those queries over to the machine learning engineer. What the machine learning engineer would do is take those queries, create like a nice code base for it, test them out, and then the data scientist and the machine learning engineer run the A/B test together, define control populations, test those model out, and then they finally put it into production, and it all becomes live, right? So in our case, basically we'll have like two teams. One would be a data science team, one would be a machine learning development team, right? But it's not that both of them would not know what they're doing, right? So all of this goes in tandem with each other, and yeah, um, that's how like you put a model into production, right? So in our case, that's how we'll put a recommendation engine into production, by having these two sets of teams, right? Now towards the end, like I would say 5 things, right? And this is something that may apply for any problem that you encounter in the industry, right? Or even in your internships, or when you're just trying to solve a problem for a firm, for yourself, for anyone, right? The first thing is that know your data well, right? understand what your data means, right? Don't just try to put the next best model on it, right? Don't get into like don't get into deep learning, don't get into all of that, jazzy stuff. Just right off the start very simple, right? Understand your data, spend a lot of time doing exploratory data analysis on your data, right? Try to figure out what relations your features have, right? Second is draw out your output expectations, right? So what is expected out towards the end? And trust me, majority of the cases that I have in my consulting experience, second is where a lot of teams would fail. They would just not, they would know their data well, they would know how to build a model, but they would just not know that for a particular use case, what is that model type that they have to build? Is it a regression model, a classification model, or a recommendation model, right? So draw out your expectations clearly right off the start. Document them, right? If it's a regression model, then you only focus on those. If it's a classification model, you focus on those. Figure out the kind of problem it is, right? And figure it out early. Third is understand the problem statement, right? So in our case, in case of the recommendation engine, we spent a lot of time trying to figure out what kind of behavior do we want to drive, right? Do we want to drive a collaborative filtering behavior or a content-based filtering behavior, right? So spend a lot of time understanding the problem statement, right? Because the second is fine and the first will be okay, but without the third, you won't be able to piece everything together, right? And fourth, again, this is something that I think I will probably get tattooed in a while. That generally, what a lot of students, what a lot of young professionals start doing is, as soon as they are given a data set, they would start picking up like TensorFlow models, they would start picking up PyTorch models, they would start picking up all the XYZ models that are there in the industry, all the deep learning models that are there in the industry, and they would just start building like a very complex solution out of it. My word of advice and caution there is always start simple. Always start with something that you can easily explain. So when you're building, say, a convolutional neural network to classify images, before you do that, create a very simple naive-based model to classify images, right? Because that will give you more insight into what your data has, what kind of biases your data has, and how you can mitigate those. Last but not the least, is ask as many questions as you can. Like, question everything. Do not take anything for granted. Generally, we as data scientists, or we as machine learning engineers, we have like a lot of biases within it. That, oh, okay, this is an image problem, let me use this model. Oh, okay, this is a text model, let me use this thing. But don't take anything for what you think. Actually verify it statistically that this makes sense. So I'll rest my case. I hope I was able to add some value to you all. And yeah, let's take some questions.
Thank you, Vaibhav. In a very short time, you have given a lot of insight and opened a lot of questions for them. And definitely your wide experience, we look forward to do some of your project. If you're doing, you have some problem, you want it to be solved through machine learning, to use data science. We have a very active research group in Amity School of Engineering and Technology, right, in Department of Computer Science. So could you please give us some problems so that together in a collaboration we can work and we can take students team into it, so that we can do a lot of problem solving in this. And thank you once again for a wonderful session. So I'm just reading out the questions.
Sure.
Vidit Saxena has asked question, how to know which regression model will give the best slope for the particular problem, and when and where to use neural network, when we can use hypothesis.
Right. So my my answer to that would be, I'll take it from the end to the start. So start off with the hypothesis first, right? So say for example, if you're doing stock market prediction, your hypothesis would be that you want to predict the price of the stock at the start of the day, right? Or at the mid of the day, or at the end of the day. That's your hypothesis. When it comes to regression, right? Figure out what kind of regression is it. Is it a time series regression? Right? Is it a multivariate regression? Is it a univariate regression? What kind of regression problem is it? The third thing is, whenever you have large amount of data, right? Large amount of data. Always take a small sample of it. Build a machine learning model. Build a very simple machine learning model on it. This can be like something which is as simple as building a linear regression model, right? And then work your way up from it, right? don't start off with building like a deep neural network and then getting into linear regression. Trust me when I say this, 80% of the times, whatever accuracy or whatever RMSE score in your case in regression, whatever RMSE score you get from a linear regression model or probably from a random forest regression model, would be almost similar to what you get from a deep learning model, right? So don't let your model solve for data, right? Solve the data for your model, right? So always get enough good feature, spend 80% of your time in feature engineering and then build the model. But specifically, what I would recommend is in terms of regression, start off with like linear regression, move your way to a decision tree based regression model like random forest or a DT regressive, and then you may start off with XGBoost. Even then, if you're still struggling, then you may look into a deep neural net architecture. I hope that answers your question.
Yeah, thank you. There's another question from Navera Kamal. This is Navera. I'm interested in data science. While exploring data set available on internet, I encountered time series data. Can you recommend some way in which we can clean such data, and what sort of machine learning models can be built for it?
Right. So time series is like one of the hot topics in the industry as well. In fact, what I can do is I can share a couple of videos that I've done before for time series models as well with you, and we can you can go through those. But specifically for your question, for a time series problem, what I would recommend is first visualize your data. Right? See from like say for example, if you have 1 year of data, visualize it for at a day level and see where all do you have values, what all are the outliers in those values. Right? First thing is that. So the first thing that you want to do is you want to remove the outliers from the data, right? Say for example, if like this year is an is an outlier, right? So if I talk about stock market prediction from a time series standpoint, this year is a really huge outlier, right? What that means is I think around March 24th or 25th, we saw a dip of 5,000 points in Sensex, right? So that is an outlier. You don't want your model tuning in on that value because that is not something that happens every day, right? That's something that happens once in a blue moon. It's a tertiary event. We have no control on it. Remove the outliers, right? Then in terms of models, I would recommend again start very simply at a very simple stage. Start with like an ARIMA model, like which is an autoregressive model. Start with a SARIMA model, ARIMAX model, and all of these, right? Again, there are a lot of packages for it. You can use stats models, you can use pi time series, and in R, these models are directly there. So start off with these simpler models, and if it doesn't work, then you can use Facebook's Profit, which is a library, to build deep neural net based time series models.
Yeah, very good. There is another question from Akanshu. Can a person use both content-based and similarity-based filtering simultaneously? Yeah, we have to go with only one approach at a time.
So this is a fantastic question. I have to say it. Generally, both of these go in tandem with each other. Why? Because it takes time and a lot of data for a collaborative filtering model to kick in. Right? You need at least like good amount of 10,000 people or 12,000 people or 1 lakh people to go through your website to be able to get to and across over a period of time to be able to get the amount of information that can actually build a good model, right? So what we do is we start off with a content-based model first, right? Because content-based model does not require user activity, right? So we start off with that. We start serving recommendations through that. And then through time, through say 6 months into the time or 8 months into the time, 9 months into the time, we switch over to a collaborative filtering model, right? And again, a collaborative filtering model would not work for a new customer. For a new customer, you would have to have a content-based model because for a new customer, you won't have any history of their buying preferences. So you start off with a content-based model and then you switch to a collaborative filtering model and use both of them. So for new customers, you use content. For old customers and repeat customers, you use a collaborative filtering model.
Yes, there's another interesting question from Raghav. How to collaborate and contribute towards new and interesting machine learning application or projects, since most of those online are pretty repetitive in nature?
This is again a fantastic question, and I'm not even kidding. This is something which when I was in college, I was also struggling with. Right? How do you collaborate? How do you contribute towards new and interesting machine learning projects? So I have a twofold answer for it. For me, and again, I can only speak from my experience. For me, it was something that I was passionate about. It was speaking something that I was passionate about. So I was really passionate about data journalism, right? So that's where I started getting data from the government websites. I started scraping those data sets and started building very preliminary models and started posting them online, right? You can find groups on Reddit. You can find groups on a lot of these channels or a lot of these data journalism groups, and I started doing those, and that actually gave me they gave me a lot of feedback to improve, right? And then we also did like quite a couple of articles together with Times of India, with Hindustan Times, and so on and so forth. And that led me to like contribute to both the economy in the sense of like publishing stuff, and also in terms of my skills to build better visualizations, to build better models, right? Second is that we're currently working in the world of open source, right? So I would suggest go on github.com, right? And there are so many projects out there. Like believe me, like you can go to scikit-learn, pick an issue, and actually start contributing to it, right? So start off with that, right? Last, which I come to think of is, reach out to your professors, reach out to like people on LinkedIn. You would find like there are a lot of these groups, right, who you can reach out to. They would have some sort of problem statement. They would already have data in majority cases, and you can like collaborate with them and form a group of people within your university and start building those out. So the answer is that a lot of times you alone can do a lot of things than having someone who can do something for you.
Yes, well, thank you. Even I was requesting you also to give us some research problem statement, so that we are finding a lot of students has very high interest on machine learning, which we always feel there's a lot of scope in machine learning. Even I remember whenever I go on a website, let's say if I find any product, let's say I have given a search on Google, and I find whenever next time I go, these product websites start on my left and right, and they want I should click. And these are the things which are very, very important. And I feel if anybody is going online, they have their own interest. And if somebody can surround them with the interest, a lot of conversion can be done. And it can really help businessmen to have good turnover, good business on that. So machine learning really playing a very important role. And I'm seeing in everywhere you can apply machine learning, you can create a model, and that model can definitely help you to grow your business, to understand your patterns, and through that you can always do forecasting. So that's why many students are interested, and Weber, we request you to give us some projects so that we do it and show, and there are a lot of scope. And with so many students like computer science and engineering, we have 3,000 plus students, 5,000 plus engineering students. So anything it comes in your mind, you might not have a time, you please give it to us. And I'm sure these young engineers can solve those problems, and because they're passionate, they have a lot of time during COVID also. So their time can be best utilized to equip them, and it can be a very good experience. So we look forward on that. There is another question. Yashwant has asked, if neural network algo can solve any problem, what is the need of other algo?
So here's the thing, right? A neural network can solve a lot of problems, right? And it is the in thing right now in the tech world, right? But what you cannot do with the neural net algorithm, because is that you cannot explain those results, right? It's very difficult to explain an output that you get out of a neural network. In case of statistical models, it is nothing but an equation, right? It will be ax plus by, or ax square plus by is equal to c, right? It's literally as simple as a mathematical equation, and explaining an equation is much easier than explaining bunch of weights in case of a neural net. So and I can give you an example of my scenario. In past 4 to 5 years of doing freelance consulting and data science consulting, both at Deloitte and for startups across, what I've seen is like actually for a neural network model to go into production, it takes a lot of effort and time. Generally, clients would not have that much time or effort, right? They would focus on something which is simple, which they can explain and build a lot of things from. And I just take one more minute and give you an example, right? in a regulated industry like healthcare or like in FSI, right? The importance of explaining the model is paramount, right? So having a deep neural network which you cannot explain, like how is it actually coming to a prediction, right? Is a big no-no in like FSI, in like financial services or in healthcare, right? And whereas over there you would still see like age-old models like naive Bayes, logistic regression are still like working in production. So always bear that in mind, that even though you can get the best possible accuracy from a deep neural network, it does not mean that it is compliant to a lot of regulations that our government has put in, or that industries across put in.
Yeah, there is another question through Abhishek. Please tell about overfitting in ML.
Right. So again, fantastic question. The overfitting in machine learning is a is a concept that means that generally when you, so let me take a step back. Generally, when you're building a machine learning model, right, you would have two sets of data. One would be a training set, another would be a testing set, right? So what you always want to do is you want to, like, you train on the training set, right? But you want to generalize that training. So you don't want your model to just understand the features of a training set, right? You want it to work for a test, for your testing set as well. What overfitting does is when you're training the model, it becomes so engrossed within your training set that it would learn like even small outliers and details of your training set. What that means is it does not generalize anymore. Rather, it specializes in your training set, right? And on the testing set, you get like really on the contrary, you get like really bad accuracy on your testing set, right? So that's what overfitting is. How can you avoid that? Is whenever you create your training and testing split, right? Whenever you're training your model, after each iteration, after each model, always look at the training accuracy and the testing accuracy, right? Your training accuracy would always be high, but if your testing accuracy is very low, right? If it's say 60% or 70%, right? And whereas your training accuracy is say 80% or 90%, then that means that you're overfitting and you need to change something in your data. Maybe you need to randomize your data, or you need to get more data, or you need to remove some variables which are deeply coupled with your target group.
Thank you, Vaibhav. There are so many questions. Could be, you have to spend whole day in that because this is such a vast topic
Right.
where a lot of interest, a lot of questions are there. And I'm sure, dear students, when you have listened, many questions which you have replied, they have given solution to many questions they have raised. So if they have a question, they can always get you on your LinkedIn profile.
Yes.
They can send you a mail. They can send us a mail. And Vaibhav, we definitely look for, because it's a very important area. In Amity, you'll be happy to know it's a very good collaborative project where we have institution from different domains. Let's say you want to do and apply machine learning in some biotech area. We have got Biotech Institute, we have got Management Institute, we have engineering. In engineering, we have many disciplines. So I'm sure if you have any idea which can be applied in any discipline, we can make an interdisciplinary team. And you rightly said, if you want to apply and work on data, you have to understand that data. So if it is a medical data, so we always suggest them to have a doctor in your team, so that doctor can give you a lot of insight about that data, because you might not understand any technical terms. So it can be a very good collaborative project, and we have a lot of experts with us. And government is also asking to do many projects by using machine learning and artificial intelligence, which is undoubtedly is a very topic of a great importance because it has a lot of benefits out of it. So we look forward to have some collaboration with you to start with a smaller and go bigger. And I'm sure, and even in our US, I don't know, you might be aware, we have taken over St. John's University campus, which is 170-acre campus in New York. And there we are giving opportunity to start company. So there are a lot of scope in machine learning to do project, to do training, to run certain programs with live projects, which we can run. And I'm sure with person like you, it can really create a big with impact and good interest among students, because you are already doing a live projects on that. You have very good understanding. So we look forward to have some longer. This could be a very good start of our friendship. We want it to go manifold so that society can be benefited, industry can be benefited, and these students should take all the challenges. In Amity, we want each student should be a success story. And I'm sure if they work on these technology for next 2 decades, 3 decades, they will not have any problem of the job. They'll be they'll be running, and company will be after them. They have expertise and experience of doing a project which is using machine learning and artificial intelligence. This is going to be the future, and I'm talking to many companies. They are looking for these professionals. They're not getting. For 100 job, only one professional is available in the market. So it's a very important area where a lot of scope and demand is there. So with this, Vaibhavji, I thank you once again for sparing your valuable time with us to give a lot of insight to all the students and faculty. And I'm sure if they got interest, they can go and find a lot of projects are there. You rightly said GitHub is there. They can upload their project on GitHub. Many projects are available on GitHub. They can see, and it is always a good learning to see somebody who has solved problem, how they have solved the problem. If you can understand that, then you can also solve another problem. So if I always say, when you want to make a car, you always dismantle car, make the car again, and then you can make a new car. So that gives you a lot of insight about that, how engineering has been done. So thank you once again, and we look forward, and thank you all the participants for attending this session. And we always want all the students to be on LinkedIn. Please be on LinkedIn and see what all are doing, what top CEO is talking about, top industry is talking about, what kind of solution they are looking through machine learning and artificial intelligence. And I'm sure you will get all answers if you go on LinkedIn and start searching. You'll get a lot of expertise available. And if you start telling your interest, they will definitely give you some modules, some projects so that you can walk upon. And once you get a project, you can always make impossible to possible with your all positive attitude and hard work. So Vaibhavji, thank you very much once again, and we look forward to have you in campus sometime post-COVID.
Sure.
And these are the kind of seminar and webinar we are organizing. We have arranged more than 1,500 webinars by industry experts, by experts from all over the world, so that they are coming, sharing their ideas, thoughts, their experience with our students and faculty, so that nobody should reinvent wheel again. Which somebody has invented, they can come and share. And it is always good to learn from other experience rather than experiencing everything on themselves and then learn. So thank you very much. And it was interesting, and we look forward to have you again.
Thank